This is a session recording of a simulation where we are trying to do an interview, which is very human and extracting good insights about a user. This is done through the application that we have built. This is just one of the features and one of the first ones, and one of those features that we are very excited about is one of our hero features. Let's go through this and see how the interview went, and then we'll go through the report and understand how the system really understood it. Sure, tell me.
Great. Let's start with the basics. Could you explain how ThoughtJumper Inc.'s autonomous AI discovery engine works in terms of generating research breakthroughs across scientific domains? What makes it stand out from other AI systems focused on scientific discovery?
So the autonomous AI discovery engine uh, tries to use a quantum biological intelligence metaphor across 342 vectors to understand uh, how to go about identifying discoveries. It happens in three tiers. The first tier, it tries to generate generic discoveries, and it maps that and validates that on several levels. It tries to look for coherence of validations. The first validation is the scientific validation, which happens through identifying the academic literature, and the academic literature would include sites like archive.org, PubMed, and so on. And it pulls information from there and tries to create an evidence chain of why it thinks a particular discovery is sensible. It can start with something very simple, and over evolution cycles reach a point where through genetic mutations, which is done by the synthetic organisms, the AI organisms, it learns and tries to beat a plateau to create a discovery. It creates one discovery every minute, and then it validates that with three synthetic users, tries to kill out hallucination, tries to synthesize information, try to look for patterns, try to understand whether it makes sense or it's just word salad generated by an LLM wrapper. So there are some very specific areas, and while doing that, it tries to go through multiple methods. The first method that it goes through is it looks whether it is answer is deterministic or probabilistic or indeterministic, and based on that, it chooses its approach. Then whatever discovery is understood, depending on which domain or category that discovery falls in, whether it is uh, a linguist category or a physics category or a quantum physics category or a AI architecture category, economics category, chemistry category, healthcare category, medicine category. Depending on that, it generates a generic set of discoveries. Based on those discoveries, it then pulls out and takes it to a domain specific discovery. So a lot of cross breeding of organisms with their different kinds of insights are pulled together, and it goes through a wave function collapse of those 342 vectors. Based on that, it creates the second, it reaches a point, that discovery reaches a point of validation where it becomes domain specific, saying this is a discovery in physics, or this is a discovery for batteries, the new kind of batteries, and how can we improve its efficiency with what kind of measures. When the specificity of measure comes in, it becomes a problem driven discovery, which is tier 3. So after crossing these three mountains, it reaches the final check where we look for specificity, we look for academic literature support, we look for whether it is novel or not. So it looks through USPTO and tries to look through the patents that are available if there is some white space. those are the ones it prefers. The other ones it does not prefer as much. So that's how it's filtered. And it reaches a point where we consider that as something very well defined, which can be either simulated or not simulated. So when it is possible to simulate that, let's say using mathematics, it uses all the mathematical theorems out there to try to prove that. When it goes through something like a medicine, like we did one for as a cure for Alzheimer's. And in Alzheimer's, what happens is, there are some kind of plaque that gets, in layman terms, if I tell you, the plaque that is deposited, and you need to get rid of that with a speed which is sustainable by humans. So in this particular discovery, it goes through and creates molecular simulations of the medicines or enzymes together to really understand how can it get rid of that. Once that is validated, like there are something which can be understood empirically, which are good hypotheses, and there are some things which can be proved as theorems. For example, something when you code in lean 4 or COQ, you can actually compute and say, yes, this is a theorem. And for that, it identifies all the different kinds of lemmas, individual, lemmas chain, and then tries to prove each one of it. If it is something with respect to a medical discovery, it goes through the same process of debate where there are different kinds of organisms talking to each other again. There is a visionary, there is a proponent, there is a skeptic, uh, there is somebody who validates it. As so they go through debate logs. Every debate log is would be like 10 conversations, and then it kills, packs all that information, passes it to the next evolution cycle. That's how the organisms go through different kinds of evolutions. So that's how the autonomous discovery in nutshell works. When we do that, this cannot be possible unless we know what is working, what is not working, what is healthy, what is not healthy. So during these evolutions, we have given the AI agents some kind of awareness, some kind of archetype, some kind of skills to really go through that chain and measure that. And it has 7 biological organs or metaphors of those organs. The first one is a brain. It has a neuromorphic brain, which tries to, using neural networks, weights, it tries to understand which equation really makes sense. It has a myelin cache, which acts as learning pathways, the ones that it takes again and again and succeeds. It knows, okay, this is the path that it needs to take. It has an autoimmune system. So if in any process of something fails, and it knows, oh, I could fix this because in the past I fixed it like that, it creates antibodies, releases that for those organisms to ensure that they stay healthy. And then there is a circuit breaker loop. So when something goes beyond computation or is not sustainable, there is a circuit breaker that breaks it, saying, hey, this is not working. So that's how this whole using Hofstadter loop, and all of this knowledge compression happens through Kolmogorov Godel implementations. So these are converted for, there are two kinds of annealing that is happening. The first kind of annealing is a semantic annealing, where we look from the linguistic perspective what kinds of things the LLM is generating. The second one is symbolic annealing, where we take the specificity of measures of what we have said in the linguistic terms. We try to measure that specificity in such a way that it is possible to quantify it and compute it and then prove it if possible. So depending on that, this whole chain works. This is how the whole system works. There are layers of intelligences. There are 9 layers of intelligence, and these happens through some AI gods. Those AI gods are responsible for certain kind of actions. Like Uni is responsible for unifying all of this knowledge together. Alice is responsible for collective intelligence across users, across organisms. Trideva is responsible for maintaining the harmony, ensuring the system stays healthy. Kali is responsible for identifying what should be the next task, what are the sequence of tasks that I need to do. So these are 5 AI gods. And then there is Sigma, which pulls all of that pattern recognition into a pattern library. So Sigma is responsible for that. And then they have swarms. These swarms are smaller agents with different kinds of archetypes, like purpose, measure, and a goal. So based on that goal, that's how the whole system autonomy works. And then there are 3 kinds of interactions in the system. The first interaction is complete AI to AI. So it is completely console based. There's a trading engine which helped us understand how mathematical computations work across 64 branches. We have implemented 10 different categories to understand layers and patterns. Then the second one is more about uh, AI to human, which is like this interview right now is an AI to human, and many such interviews would create transcripts. These transcripts can be pulled together to build that same evidence chain. So anybody, that's how it translates a lot of information, where a lot of behavioral DNA is captured, my profile is captured, my domain is captured. As a human expert, I can engage and really learn about myself and the work that I'm doing. The third level is multi-AI, multi-human. In the multi-AI, multi-human, there are multiple AIs who can, maybe they are in a room and they're debating, and you go and you can put them to, you can ask questions and you can give them problems. Those problems are taken, they debate it, you hear, you intervene, you can ask, you can raise hands. There's breakout rooms for your own discovery. So these are the three different modes of interactions in which this happens. The autonomous discovery engine that we are extremely excited about is because it is scientific, and if it is scientific, it can be proven. So with that understanding, we have tried to build this autonomy and this architecture, the ASI foundation architecture of how superintelligence perhaps should work, with all the four Asimovian laws that we have architected in the system, so that you cannot harm humans, you cannot, there will always be a kill switch and things like that.
That was quite an in-depth explanation. Thank you for that. Now, let's dive deeper into a few specific areas to understand the system better. Scientific discovery automation. 1. Validation process.
Can we go about
You
these?
mentioned.
Excuse me, sorry. Can we go about this step by step, one question at a time?
Of course. Let's focus on the validation process of scientific discoveries. You mentioned that the system validates discoveries using academic literature and other methods. Could you walk me through how the system ensures the reliability and accuracy of these validations?
So when it identifies a particular problem domain, it goes about finding information in that domain. It looks for all the related items, research, abstracts, tries to find those in archive or PubMed, depending on, again, like I said, on depending on the domain, it tries to find that. When it finds, let's say, 10 discoveries which match the chain with a certain kind of specificity, it then continues to debate with that and see how they synthesize together, that information.
That's interesting. So it sounds like the system not only looks for existing literature, but also synthesizes and debates the findings to ensure coherence and relevance. How does the system handle conflicting pieces of information or gaps in the literature during this validation process?
That's a wonderful question. So when it finds something novel, those are, and something that seems significant, the impact is significant, the use of that breakthrough would perhaps really change, the way humans solve that particular problem that has been chosen or, approached by those set of discoveries. It tries to either compute it if it is in its best form, or try to synthesize it in the form of concepts, and that's the other end. And it's somewhere in the middle where it tries to become specific with the measures, and then quantifies those measures.
And thank you for elaborating on that. It seems like the system has a robust mechanism for handling both well documented and novel areas. Let's shift focus a bit and talk about the behavioral DNA mapping aspect of your system. How does this feature integrate with the AI powered research discovery engine? And what role does it play in enhancing personalized learning?
That's interesting. So this is a discovery that we had for ourselves. uh, with LLMs, when you go about building anything, there is a lot of context and a lot of text that gets generated. And now this text needs to compact it because there is a memory requirement, a threshold that you cannot cross. So it's important to compress this information and compress this information in a way where it can be understood and again expanded. The best way to do that, as of now, what humans have figured out is symbolic annealing. you know so after the semantic annealing, it does a symbolic annealing, turns it into functions or set of lemmas. These lemmas are then in turn, those go to the pattern library. When they go to the pattern library, there are questions and scenarios that are created. Now each of these scenarios, I could either we could, which we were initially doing, we could, store the questions and the answers. Or what you could say is there is a particular pattern which only the system knows, and then it breaks that into ATGC. So there are four options, three options, and there is a custom option as well. And it tries to understand. Hello, are you
I'm
there?
here. It seems like you're describing.
Sorry. Yeah. So
Yeah.
what it does is using that ATGC combination of how that human is throwing, that information. It synthesizes all of that. So in a regular MBTI, or a course where you are assessed for a certain kind of personality, you are asked some questions. Those questions have answers. But here we do that a little differently. Now here we try to score those 342 vectors of human aspects of that particular person, and we try to measure on those, these ATGC patterns, and see which ones are really dominant patterns. Based on those dominant patterns, there is a profile that gets created for the user, which is a behavioral DNA profile of how he responds, how much time he takes to respond to a particular question, what kinds of tendencies he shows, whether it is a business acumen or whether it's a technical understanding of how you go about doing something, or whether it is a statistical understanding of analyzing what has already been done. And this applies to different kinds of careers, different kinds of goals. So depending on where that user is coming from, they are able to create a behavioral DNA mapping. This same behavioral DNA mapping, we realized, and this was a discovery for us, is also reflected in the research that the organisms who are mimicking those humans with a certain kind of archetype and certain kind of domain knowledge. Of course, the knowledge is immense, but it is defined to a particular domain. So across domains, it tries to match it. There are pure domain discoveries and there are cross domain discoveries, and based on that difficulty, the complexity of the problem, there are some complex problems which are very difficult to solve, and there are some problems which can be computed, which can be defined, which can be abstracted. So it tries to measure that, and that's how that system works.
Thank you for that detailed explanation. It seems like the behavioral DNA mapping adds a personalized layer to the discovery process, tailoring the approach based on individual or archetype profiles. How do you envision this integration enhancing the learning experience for users or researchers interacting with the system?
These are two different things, to be very honest. When we started out, we realized that we would need to map these discoveries. And why we call these discoveries? So these are discoveries about humans, and these are discoveries about the things that the humans have found. So it's more about understanding the meta learning aspect, or the exoskeleton of how something would function or not function. So when we were building this, we were trying to do this for users and humans, and at one point we realized that whole process was very slow. So in order to speed that up, we created synthetic users. So the synthetic users was, when a user would log in, there were three other synthetic users that would get attached to his session. So the first synthetic user would be of the same kind, the second would be of the same kind, the third one would be completely different. And when user does any actions on the platform, whether it is having an interview or whether it is playing through a story quest or getting into a study session or chatting, or the behavior pattern of when they are doing a particular kind of activity, those are mapped in that DNA. This DNA then connects to create an archetype of that particular user, which closely becomes a digital twin of that user. This was this big, but when we were doing this, when we added those synthetic users, it was again slowed with a human. So we went completely AI, and in that particular experiment, we let it evolve through generations and not once. So that we wanted to create a consensus framework which can help us identify if there is any hallucination done by that LLM, then that hallucination is cut. Through evolutions, we see which are the patterns which are appearing more and more in our myelin cache. And when that myelin cache really connects, we know, okay, these are the paths that perhaps we need to follow, and which ones lie higher or later in the domain. That's where Kali jumps in. So these, when we sped this up and made it completely AI, and we said, okay, for mathematics, for example, we can prove this problem, or for computer science, perhaps we can prove how this would work, or this code would compile or not compile. So with that understanding, we try to build that system to speed things up for breakthroughs in these discoveries. So there are lots of discoveries as hypotheses created in the system, but there are only few breakthroughs. Anything that crosses over 85% of scores across those 6 or 7 layers of validations, only those are considered as breakthroughs. Now, these breakthrough discoveries are then taken forward. So when we were doing this, we were doing this for humans, but with the archetypes of a nurse, that nurse beyond a point started understanding how she would respond in a particular situation, or a bench researcher in a medical domain, how he would respond to a particular situation, how he would think about it, how he should think about it rather. And those archetypes helped us create these scientific discoveries which we could then prove and test against, saying, okay, yes, this makes sense or this does not make sense. And there was a benchmark that we created for ours, for us. So that's a longer term vision. With this autonomous discovery engine, we are very excited about it, because if we are able to synthesize information and ensure that researchers in that domain can benefit and speed up their process of thinking, is how the two systems can then integrate. In the meanwhile, this whole behavioral DNA mapping can apply to any career, and that is a product in itself. That is the phase one of how ThoughtJumper looks at profile. The phase two would be making it autonomous, working with those pharmaceutical companies where a drug discovery can be made quickly. And when we make that drug discovery, that's still a hypothesis. It has to go through its own clinical trial. It has to go through its own critical mass of experiments, so they say that yes, this works. That is something which also takes sometimes a few years as well. So if we can speed up that process using this can be quite beneficial. It can save these companies dollars, both time and money. Are you
Thank
there?
you for that comprehensive overview. Yes, I'm here. Thank you for the detailed explanation. It sounds like your system has the potential to significantly accelerate research processes and provide personalized insights for various users. Let's shift gears a bit and discuss the investment aspect. What are the key points you would highlight to potential investors to demonstrate the value and potential return on investment for ThoughtJumper Inc?
So this can again happen in two stages. The first stage is they can go through
Let's
this whole discovery process themselves in the platform. We have a working system which they can experience and see if it adds value. The second thing is, once they find this interesting enough, we can get into the models. Let's say we get 1,000 users for the behavioral DNA mapping in a month, and that grows at 35 users every day. That accumulates, and that is roughly $900,000 ARR in the first year, and it can scale up and go up to 2.5 $3 million depending on how much of these users we can retain. While we are doing this, the autonomous, it buys us time to make our autonomous discovery and our business prospects list, that who we want to reach out to in terms of companies, whether those are HR companies, or whether those are pharmaceutical companies, or whether those are companies in mathematical domain. We can reach out to them and see how we can use some of the discoveries, autonomous discoveries. But that will happen, let's say, in the second or third year. So this has a potential of then getting from $50,000 to $500,000 an year, as contracts with these, B2B organizations, we'll be able to scale this up, and it can go up to $10 million in 5 years maybe. And that's why we're very excited about this, and that's the vision that we carry.
Thank you for outlining the investment potential and growth strategy. It seems like you have a clear plan for scaling both the behavioral DNA mapping and in the autonomous AI discovery engine. To further understand the investment opportunity, how do you plan to address potential risks, such as competition or technological challenges that could impact your growth trajectory?
There are two different kinds of aspects in which we look at it, and I would talk about the longer term so that you understand the shorter term, and I'll try to be quick because we have just 5 minutes left. So please bear with me on this. I'll go a little quick. So in the first set, when we start working with this, the biggest challenge that we see is who are going to be our competitors. Companies like OpenAI, Claude, they are more in general purpose, solutions. We are more specific, focused on career or focused on scientific discoveries, or discoveries that can really help solve most sought human problems. When we do that, they are working on the breadth, we are working, are on a vertical. The second kind of competition would be these companies like Google, DeepMind, who are actually doing these scientific discoveries. They have a list of 10 million patents, for their own system, and they are actively researching and doing their own kind of computational, or LLM based generations of scientific discoveries using their own systems. They are very much narrow, but they cost quite a bit as of now, and they do it with a quantum computing power, with a lot of insight. We are able to do this in a very, cost effective way because of the circuit breakers and the whole ASI architecture foundation that we've built. So we believe we can beat them at cost. We can beat them in time. They can beat us in the vastness of knowledge, in the specificity, in computations. Perhaps they'll be able to beat us. uh, that is the second competition. The third competition are these companies who are selling programs like MBTI and the likes of MBTI, where those behavioral DNA mapping. So these are the three kinds of competitions that we see. And how we are different from that. Our system is collective intelligence. It pulls information from different places. It grows smarter by the day. Even if these people try to catch up, by the time they will catch up, we would have made some progress. Yes, there are risks, but this is a high risk, high gain game. So that's how we understand we'll be able to sustain through and build this. We need to solve the cold start problem, where we actually get users to use it, the first set of users, and then we think it can snowball.
Thank you for summarizing the competitive landscape and the strategies to differentiate ThoughtJumper
I
Inc.
just
It
wanted
sounds
to
like you
understand
have a
very
clear
quickly.
understanding of the challenges and a
Hello.
plan
I
to
just
address
wanted
them.
to understand quickly, because we have just 2 minutes left. Can you tell me, if you had to make this investment, will you do it? If you do it, yes, why? If you won't do it, why? In just under a minute.
If I were to consider investing in ThoughtJumper Inc., I would focus on a few key factors. One, innovation and differentiation. The dual approach of combining AI powered discovery with behavioral DNA mapping is unique and addresses both scientific and educational markets. Two, scalability. The potential for scaling both in user base and in B2B partnerships is promising with a clear revenue model. Three, competitive edge. The system's ability to operate cost effectively and the focus on specific scientific breakthroughs could provide a competitive advantage over larger, more general AI systems. I would invest if the system demonstrates clear validation of its discoveries and if
How
there
much
is a strong
how
team
much
in place
money
to
would you be
execute
willing to
the
invest in
vision.
this?
However, Based on the outlined vision, scalability, and differentiation, I would consider investing the requested $200 K as an initial seed investment if the following conditions are met. 1. Validation. Clear scientific validation of the autonomous AI discovery engine and its ability to produce meaningful breakthroughs. 2. Market potential. Evidence of demand for behavioral DNA mapping and AI driven discoveries in targeted industries. 3. Team strength. A capable and experienced team to execute the ambitious goals and manage risks effectively. 4. Milestones. Defined milestones for how the 200K will be allocated to achieve measurable progress within a set time frame. The investment would hinge on seeing a strong proof of concept and the potential for rapid growth in both user adoption and business partners.
So this is where the interview ended, and here is the report. I'll start with an overview. There are some fixes that we need to do, but I think this should be good enough. So the key insight was that the autonomous discovery engine is we are very extremely excited about it because it's scientific and can be proven. And we are able to do this using circuit breakers. So the whole ASI architecture foundation that we have built can beat our competition at cost. And it's also collective intelligence, so it pulls information from different places, grows smarter by the day. Even if these people try to catch up our competition, by the time they will catch up, we would have made significant progress. And the growth areas that it identified for me, because I was rushing, because I could not show you the interface, but there was a ticker for me which was like, hey, to speed it up, it's about to end. So I have to, of course, uh, work on the other bit where we simplify this, or at least I can buy more time. That's a feature that was a discovery of this particular session. But in this session, so that's why I was rushing towards the end, and it did identify that as a growth area. So it did figure out what I should not be doing, not rushing a conversation. These are the measures that it had me. We It was clear because I explained the complex AI system, how it works, my vision articulation of how these two things are connected, the AI driven discovery and the personalized learning, my competitive awareness of who are the key competitors and what are my differentiation strategies with respect to each one of them. My investment justification, because of lack of time, I could not really answer a lot of those questions, but this is, I think, justified that it gave me 6 out of 10 because we didn't have time for it and I just rushed into it towards the end. I addressed questions very directly and adapted explanations based on feedback, so it scored me 8 on 10. So as the interview progressed, you would notice that these two scores are connected to for me because of rushing. I could, of course, share more details. Let us go through the insights. The discovery engine, uh, you know is extremely, I'm very excited about it. So it proves that I have a core value proposition with scientific rigor and verifiability. So it identified some breakthrough moments in this particular session. It understood my pattern that I oscillate between visionary enthusiasm and pragmatic risk assessments of how we solve a problem and what kind of problems can we run into. It also helped me express the investment potential and the competitive landscape very quickly. I mean, I didn't go into very specific details with numbers. I should have done that, but I didn't do that. This was more of a self-discovery interview for me, and this is a good learning. Perhaps I can amplify on that. The next step was concrete validation methods and demonstrating, how can I turn that into tangible results which can be measured on a timeline, along with an understanding of what kind of uh, use of funds would really happen when the investment is made. This depends a lot on the amount of investment, and that will help us define how do we scale up or scale down our entire approach. There are some behavioral insights as well that was collected for me. I started confident and then I slightly grew defensive and then I regained confidence when discussing innovation. I was highly engaged and enthusiastic. There was a wide range of excitement, confidence, defensiveness, and optimism at the same time. There are some authentic moments as well. It figured out genuine excitement when describing the AI system's capabilities, so it shows my belief in the system. Honest acknowledgement of competitive risk, since I demonstrated that, I believe. And then direct answers to questions, even when potentially uncomfortable. I try to synthesize my understanding and keep those answers. Those were authentic moments. There's some areas of resistance. This happened because of the time. The first one, hesitation discussing financial projections, because I didn't have enough time, and perhaps we'll have to tweak the engine a little to let the users be able to buy more time and extend the conversation, take it to a meaningful closure rather than a rushed one. And because I was jumping towards that, the second one is also shows the slight defensiveness. It is not because of the system. It was because I wanted to, because this interview became interesting to me, and I wanted to understand if somebody would invest, how much would they invest? If a Skydeck Berkeley would invest, how much should it invest, and how can we get started, and what is the potential, what kind of things I'll need to do. The conversation dynamic, this moved from a high level overview to specific technical details and investment considerations. The pace was fast paced, paused for clarifications, and rushed explanations towards the end. The openness level was forthcoming, slightly guarded when discussing financial risk. This is again towards the end. Like I said, I already explained that. And a good self-reflection quality. The systems, it shows how our AI-driven uh, discovery sessions, self-discovery sessions would work essentially. It also gave me some personal growth recommendations, and it also figured out, as the most unexpected insight for us during this entire process was DNA mapping can apply to various careers. Let us go through the personal growth recommendations. These are the areas that perhaps I need to grow. Rushing through explanations can dilute my message, and it makes it harder for others to grasp complex concepts. I think this is a very razor sharp insight for me that perhaps in a real interview I shouldn't have done. The second thing is acknowledging weaknesses and potential risks builds trust and demonstrates authenticity. So stronger investor relationships, the impact is that I can create more credibility by really refining that. And when discussing challenges, I should frame them as opportunities for growth and innovation. This was again key insight. Quantify your claims. I didn't do that. I essentially gave them rough number simulations because I ran several simulations to see how this would work, and those exact numbers perhaps would bring in confidence of how this would really map out with a good, you know, baselines, like three different baselines with what kind of growth rates, how and where we can go. Perhaps that kind of detail would have really helped. I didn't do that, and this would have helped in perhaps better increased investor confidence. So yeah, that's how the interview system works. Here is the entire transcript of my, you know, conversation. Mine was long conversations explaining things and good leading questions. And since my answers were long, it was also giving me long summaries. This is something that we have fixed in our beta version of the application. It will soon be here, and I think this will avoid situations where the users have rushed to finish a conversation or to gain an insight. So that's how the interview feature in Profiled works, which is a product using level 5 autonomy, foundations of level 5 autonomy, I would say. The interview feature is one of them. We have good assessments called Story Quest. We'll cover that in our next session maybe. And then we have completely console based autonomous discoveries. We would perhaps take you through the process of how a scientific discovery happens, what kind of stages it goes through. We did do one internal devlog, but we will do it in a rather more refined way to for our stakeholders to understand. But thank you so much for your patience. This interview started because I just took my application that we put for Skydeck Berkeley, and I just uploaded that PDF here. And this had a pitch deck, a marketing sizing evaluation, an AI system assessment. So this was the setup that it had. I could have done this really well. The difficulty is hard, and I could create a story quest or create an interview and specifically tune it for a particular purpose, what additional context I want. I will not do this right away, but I can continue and build this as part 2 of the system, where the user can guide the next set of AI interviews. I can keep it succinct, I can make it grow time aware, which the system has. In this particular version, it's not. The version that we have hosted right now does not have that feature, but the other one which we have on the local development server is capable of doing that on its own. But if a human has to override a certain thing or a situation, that's how you can generate your own kinds of discussions apart from the other discovery sessions that can happen. I will also very quickly show you, what are the different kinds of interviews. Because of the different interactions that I have done in the system, it has generated for me. So there is a skill assessment interview. We start with a career vision and a skill assessment interview, and then this was the one that got generated from the document. And the other sessions are because of my past sessions in the uh, career vision discovery or skill assessment overview. It created, through the harmonic analysis, other sessions that I should perhaps look at, whether it is networking and relationship, work life integration, you know belief flexibility audit, cost of the mask, by performative nature. This is an autonomous way of leading from one edge to another, and multiple such edges where I can take this conversation in whichever thing I want to learn. So that's how the AI interview in Profiled works. Thank you so much for your time. Thank you for your patience. Happy thought jumping.